Welcome to the Cannabis Cultivation and Science Podcast. I'm your host, Tad Hussey of Kiss Organics. This is the podcast where we discuss the cutting edge of growing from a science-based perspective and draw on top experts from around the industry to share their wisdom and knowledge. As you probably already know, very little research exists on cannabis and much of it is not shared openly. I was so excited to see these papers and doctoral thesis from my next guest. You may wish to check out the publications prior to listening to this podcast, or if you want to read them after, you can go to the podcast page. Go to www.kisorganics.com and click on podcast on the top of the page. And while you're there, don't forget to sign up for our newsletter on the homepage to stay up to date on the latest research we are doing as well. My guest this week is Deron Caplan. Deron is a horticultural scientist and the director of plant science at Flowr in Kelowna, BC. That's spelled Flowr. He was the first person in North America to earn a PhD with research focused on cannabis production. Dr. Caplan has written and published several peer-reviewed articles on cannabis production, focusing on irrigation, growing media, fertilization, and propagation. He has testified on cannabis production before the Canadian Senate Standing Committee on Agriculture and Forestry and has provided expert commentary on cannabis for a variety of media outlets, including CBC, Nature, and Rolling Stone magazine. Now on to the show. Hi, Deron. Thanks for coming on the show today.
Hi, thanks for having me.
Yeah, why don't we start off giving listeners a little bit of your background and how you got into, well, essentially cannabis research in your PhD.
Yeah, so I've kind of always been interested in plant science and horticulture specifically. I studied environmental science in undergrad, and when I was looking for graduate research, it was about the time when they were talking about legalizing cannabis for recreational purposes in Canada. And I was talking to some prospective advisors, and one of them was considering doing some research in cannabis, who became my advisor, Dr. Yubin Zhang at the University of Guelph. And what was so exciting to me about cannabis, not that I was so involved in in cannabis specifically, but there's no research on any horticultural production aspects of cannabis. And for a new scientist starting in an industry where you could kind of learn so much so quickly and kind of decide what you want to learn was incredibly exciting for me. So it was kind of an obvious choice. And kind of the rest was history. I got deep into cannabis, and I've been in the industry for about 5 years doing kind of nothing but.
Yeah, that's so cool. That's the thing I love about it too, is there's so much to be discovered. There's so few horticultural plants and crops that are even out there anymore that don't have quite a body of research around them. So I too am really passionate about the fact that you can do a lot of really exciting work and really discover stuff pretty quickly with cannabis.
Yeah, it's really amazing.
Yeah. Well, you know what? Why don't we just dive right in with some of these papers? One of the first ones here is entitled, let's see here. Let me make sure I have the right one in front of me. Oh, optimal rate of organic fertilizer during the vegetative stage for cannabis grown in 2 core-based substrates. Do you want to talk a little bit about that study and kind of give listeners a little background? And just to be clear, I will put links to all of these studies if people really want to dive into the details of them. They'll be available on the podcast page. Okay,
yeah. So the first study that I did in my graduate research was on growing substrates and on organic fertilization. And so because there was so little research, there was almost nothing on fertilizer or on growing media for that was cannabis specific. We kind of started from ground up. So we looked at determining optimal fertilizer or fertilization rates for cannabis during both the vegetative stage and the flowering stage. And we also custom formulated growing substrates for both of those stages to coincide with those fertilizers. And we were working with a licensed cannabis producer in Ontario called Vivo Cannabis, and they were supporting all of this research. And they were using, they kind of wanted to improve their systems, and so we tailored our research somewhat to try and help them, but also just trying to increase the body of knowledge on these topics.
Great. So tell me a little bit about sort of how you established the methodology here and what you were exactly testing. So you mentioned you were using cocoa core based media for your substrate, and then you fed different levels of organic fertilizer. Can you talk about what that organic fertilizer was, how you fed it, and a little bit about maybe the growth chamber?
Yeah, for sure. So all of these trials were in controlled environment growth chambers, and these are just very large kind of walk-in growth chambers that you can really tightly control the environment, and that's very important for making these results applicable to other growing environments, because if you have a lot of variability elsewhere, it's hard to kind of tease out the effects of the fertilizer or the growing medium, which, for example, if the lighting is not uniform, the lighting will probably have a much stronger effect than the fertilizer. So we custom developed these two growing media with different container capacities. So one of them was with a higher container capacity, meaning that it holds more water after it's saturated. And then one with a lower container capacity. So these are often considered a high porosity, or this ProMix HP, which is a high porosity growing medium. That's an example of one. So we formulated these two based on their container capacities to see if cannabis prefers a drier growing medium or a wetter growing medium. And we did that in both vegetative and flowering stages. And then in a full factorial experiment, we applied 5 different fertilizer rates to each of these growing mediums. And we did that we did a whole experiment during the vegetative stage, and in another publication, we did it in the flowering stage with 2 other growing mediums that we also developed. And from that, we teased out what the optimal rate of a complete fertilizer is for both of these stages in these growing mediums.
Okay, and one thing I want to highlight from your paper, this is a direct quote actually from that you pulled out relating to the work of Dr. Zhang, your advisor. You mentioned different substrates have different physical and chemical properties. Therefore, it is essential to fertigate plants accordingly to ensure an adequate root zone environment. So the big takeaway, I think, is that we need to realize that this study is very specific to coco coir in the environment that you had created. And we can't necessarily extrapolate this data across peat moss and rockwool and ebb and flow systems and things like that. But that you were able to get, a good foundation for some possibilities for NPK levels for cannabis during the vegetative state.
That's right. It is one thing about these publications, or any horticultural research for that matter, is that they're designed in that they should be widely applicable, but obviously there's limitations. So depending on your growing system, if you're using, like you say, a hydroponic growing system with rockwool, compared to something like what we used with organic nutrients and coco coir, you're going to have a very different effect. But the general trend is probably applicable. So what we found is that there is a maximum yield at a certain nutrient concentration of this organic nutrient. So you're going to find decreasing yields after a certain rate, and you can use the salt content in the substrate maybe as an indicator of that. And also we found that if you fertilize too much, then you're actually getting a dilution effect on some of the cannabinoids. And that's probably applicable kind of across the board. It's because it's likely a response to high salinity in the growing media.
Yeah, I saw that. I thought that was really interesting. So what would you say, based on your, the environment that you created here with nutrients, what did you find to be the optimal sort of NPK level for cannabis based on this test result in coco coir with your study?
So we didn't actually look at different NPK levels. This was one complete fertilizer for the vegetative stage and a different complete fertilizer for the flowering stage. And what we looked at was the rate of that fertilizer. So basically, we're determining if cannabis was a heavy feeder, a light feeder in general, in this one cultivar specifically. And we weren't actually looking at all about the NPK ratios. Okay,
so you had a specific NPK fertilizer.
That's right.
And you were looking at just the concentration that you fed that fertilizer, what was optimal. That makes sense. So you're not necessarily looking at how to adjust, nitrogen, phosphorus, potassium, and the variety of other anions and cations that the plant can uptake, but rather just whatever concentration was best in your environment.
That's right.
So based on that, something you mentioned there, I just wanted to highlight. You mentioned that you think salinity has an effect, but that you actually saw a decrease in certain cannabinoids and THC when you hit a certain level of fertigation. Can you just talk a little bit more about that?
That's right. So we found that up to a certain point, the increasing fertilizer would increase the yield, would increase cannabinoid content, and that was positive. But after a certain point, there was decreasing returns, and then after at a fairly high rate, we'd actually found a dilution of we found THC, THCA, and CBGA in this cultivar.
Those all decreased when you
That's right.
hit a certain concentration. And just to kind of expand out on that, I'm curious why you chose organic fertilizer, because it's so much more common in academic research to use mineral salts or chemical fertilizers for the ability to really control uptake. Can you talk a little bit about that?
Yeah, that was a fairly difficult choice. One part of that was that the producer that we were working with was growing organically. So we wanted to match what they were doing they were funding the project. We wanted to help them as much as we could. But we also had environmental aspect to this. We're using coco coir because a lot of growers are moving towards coco coir as an environmentally sustainable alternative to peat. I won't get into that argument, but it's some consider it more environmentally sustainable. And we wanted to have that angle. And yes, it would have been more widely applicable if we did salts. It would, for your information, we're actually doing that now in the same lab. But we wanted to focus on, this being completely organic and sustainable.
Okay. Yeah. I mean, the coco coir versus peat argument could go for an entire podcast. And I have my opinion, and I'm sure you have one too. So we won't get into that too much. But I guess my question relating that too is how do you feel nutrient uptake relates to the ability to do this research with an organic nutrient? I mean, a lot of what the growers that I work with are doing, and I know you're good friends with David Bernard Perron, who's a friend of mine as well. The idea of putting in a lot of these dry amendments in meal forms directly into a living soil, and not really having as much control over uptake, that you have that nutrient cycling process that's being really driven by plant exudates and, microbial activity. How does that factor in when you're trying to do research, or how that might impact, I guess, the results of a study like this using organic fertilizer?
Yeah, studying organic fertilizer is incredibly complex, as I'm sure you know, because from listening to your podcast, I know you're very familiar with that work. There's a million factors, and it's very hard to control for them. And so, in my opinion, it's at this point it's impossible to control for a lot of those factors. It's really kind of just finding a solution that works and understanding that we're not going to understand why it works at this point in time, and leaving that for a little bit later when we have some more time to tease apart the microbial interactions, how nitrogen breaks down and the different forms of nitrogen and other macro micronutrients. It's fairly complex, but growers still need to have answers to these questions now because they are growing organically, and they still need these practical research to support their activities.
I like that. So essentially what you're doing is looking for trends, like you mentioned, that can be sort of possibly extrapolated or used across other forms of growing. I know with the work I'm doing with Ben Higgins and Nate over at Gold Leaf Gardens, what we try and do is say, okay, living soil, this microbial diversity, that's just one variable. And we can't control it. We can't fully understand it, but we can control for it and say that all of our replications are going to be in a similar soil mix with, similar microbial levels and biomass, and then we can make one change in, say, lighting or a cultivar or our nutrient levels in that system, and then try and figure out sort of a trend based on that. But we're not, like you said, we're not going to fully understand exactly how the process is working. And that's one of the challenges I find with any organic research is a lot of researchers don't want to do that work because they can't control every aspect of plant growth. Some of it is up to sort of that microbial response and interaction.
Exactly. It becomes much more of kind of applied science than pure science. And that, for a lot of researchers, that's fairly difficult because, again, we don't know much about cannabis. So, why not start from the beginning? But we also, all of North America jumped into this industry, and we have hundreds of growers who already need this information. So giving them something that's useful, for me at this point, is a little bit more important than really understanding every single aspect of it.
Yeah, I love that. So what would be your, I know we've talked about it a little bit, but let's just say, what were your big takeaways from this paper? And then also the flowering paper. So essentially a very similar trial, but looking at organic fertilizer rates during the flowering stage. What would be your big sort of like highlight points for growers looking at the research that you did?
Yeah, so I'll break it down by growth stage. So in the vegetative stage, we found that cannabis can tolerate a range of growing media parameters. So we had the wetter substrate and the drier substrate performed well in both. We found a relatively high rate of organic fertilizer to be optimum. So if you're looking at milligrams of nitrogen per liter, equivalent of a complete fertilizer, it's on the high end compared to most other crops. So if you're looking at, if you know your nitrogen rates for tomatoes, for example, in organic fertilizer, you can probably fit it in with that, or maybe even a little bit higher. So that's, as a general rule, I think that's fairly applicable kind of across the board. In terms of the flowering stage, we had some more complex results. So again, we had increasing yield with increasing fertilizer rate, and that was for both growing substrates. But we found that the drier growing substrate, the higher porosity one, produced 13 or 11% higher yields and also larger plants. So it's likely that cannabis in the flowering stage prefers a drier substrate. And to put that in context, because it's a drier substrate, it needed to be irrigated more frequently. So it's hard to tease apart whether it was increased irrigation frequency that it likes or whether it likes a drier substrate. But either way, you'll have the same effect by using a drier substrate.
That's really interesting. And anecdotally, we've been doing a lot more with blue mats, which is an osmosis-based system that regulates moisture or moisture level in soil and keeps it even. So it's sort of a drip irrigation system that is based off of the moisture content of the soil. So you're maintaining it within a very small range. And we've, again, this is just some really preliminary work with gold leaf, but we found actually substantially increased yields by that more frequent watering. And the hypothesis is that we're getting better nutrient cycling because the microbes are being held in a range of moisture content that is optimal for them to cycle these nutrients for the plant. But again, this is all really preliminary research.
That makes a lot of sense, to be honest. In kind of looking into the literature on this subject, I did quite a bit of research on irrigation for cannabis as well, and I think we'll talk about that later. But increased frequency has a lot of benefits, not just on the microbial populations, but also just in making nutrients more available, because most nutrients are actually transported through mass transport with the water. So if there's more water, then it's more likely that the plant can uptake the nutrients. So that makes a lot of sense. Okay,
that's interesting. So one of the things though about this two studies that I noticed that you highlighted was that the yield increased with the increasing fertilizer rate. With one of them, what you call U2 HP, your yield reached a maximum, and in the U2 yield increased linearly Do you want to just touch on that a little bit in terms of your yields? And I know you mentioned that your yields were a little bit lower than what you've seen as an industry standard or what you were using for an industry standard.
That's right. So in terms of that kind of plateau that we saw in the drier substrate, and that's the U2HP, in general, the yield was higher. So we believe that it was able to reach a plateau. And so there was, you can kind of see more of a maximum at that point. And we don't think that the wetter substrate actually reached that plateau. So that is kind of how we explain that difference in the trend with increasing fertilizer rate on yield.
Okay, and you touch on pH too a little bit. Can you talk a little bit about sort of what you noticed in terms of pH range and how that might have affected yield?
Off the top of my head, I can't recall the ranges that we found were optimum, but we generally found that during both growth stages, that cannabis had a fairly wide range of pH tolerances, and we didn't do tissue nutrient analysis to quantify that, but just being horticultural scientists, we have a fairly general idea of when our plants are they're nutrient deficient, so they're showing signs of high or low pH. And it's generally believed that you want to keep cannabis at a pretty tight range of pH, especially with hydroponics. But we found that there was almost no difference with a higher or lower pH range, quite a bit outside of the normal range.
Yeah, anecdotally, I've found the same thing with a lot of different soil tests that I've seen. I've seen some soil tests where the pH is quite high, very alkaline, and yet visually and with growers, their yields are still quite good. It seems to tolerate, like you mentioned, quite a wide range of pH. In your paper here, you say, within the measured range of substrate pH, with a means of 5.1 to 7.4 in the flowering stage, there were no visual signs of pH-induced disorders. This observation overlaps the acceptable range cited in Caplan et al. 2017 of 6.7 to 7.2 for the flowering stage.
Yeah, I'm glad you have that in front of you.
Yeah.
So we could get quite high in pH, and again, there was no visible symptoms of nutrient disorder. So.
Yeah, I just thought that was really interesting. So I did want to touch on that. But I mean, there's a lot more in these papers. I know we're not going to cover everything. Was there anything else you wanted to talk about those two before we move on to the other two, which I think are even more interesting in terms of some of the results?
Yeah, well, in the flowering stage, I just want to talk about how the increasing fertilizer rate influenced some of the cannabinoids. And so I briefly touched on this in the beginning, but it wasn't all the cannabinoids that had a dilution effect with increasing fertilizer. And it's not a dilution in terms of absolute concentration in the flower, but it's a dilution in terms of the grams of THC or THCA or CBG per plant. So it's a function of yield and of concentration. And effectively, if you're trying to, if your target is to produce as much THC as possible, you have decreasing returns if you are increasing your fertilizer rate past the optimum that we figured out. And you'd have to figure out your own optimum in your production environment. But there's no benefit even if you're seeing a little bit, increasing yields, it's not always better to keep increasing the fertilizer rate because you're not increasing your THC or your THCA or your CBGA.
That's really interesting. Yeah, and the fertilizer that you used, I don't have that part in front of me right now. It's somewhere in this stack of papers, but I think it was around like a 4.12, 4.11.
Yeah, that's right. For the vegetative stage, it was a 4, 1.3, 1.7.
Okay.
And then for the flowering stage, it was a 2.8 and 2, 0.8, 3.2.
That's really interesting because I saw another gentleman with a fertilizer company at a soil scientist convention or society meeting, and he was saying 4.11 was the levels that he targeted. One thing that I found, which seems similar to the fertilizer you're using, is potassium seems to be more of a controlling variable for overall plant yield than phosphorus, because I know that in this industry, everyone thinks we need more and more phosphorus for flowering, but it seems to be massively over applied based on the research I've seen. Can you touch a little bit about, I know we need to talk about nitrogen too, but let's talk a little about phosphorus and potassium and sort of what your findings are with cannabis.
Yeah, I'm not incredibly familiar with this, but in my kind of general impression is that phosphorus is often overapplied in agriculture, and that's because it doesn't do all that much damage if you overapply it. But there's a certain low range that you'd probably have equal results with. But say if you were to double or triple it, you might have the same results. And for a grower, it doesn't make much of a difference. But for the environment, for example, phosphorus is one of the most damaging components of fertilizer. And so it really does have some implications if we're overutilizing phosphorus.
Yeah, I'm glad you mentioned the environmental impacts, because to me that's the biggest reason for us to limit phosphorus, because the cannabis industry is a big culprit of that. Can we talk a little bit about nitrogen? Because I asked you a question off air about how when you read these papers, it's all correlated around nitrogen or N per liter. And then you kind of explained that to me a little bit further. Can you kind of reiterate that for listeners?
Yeah. So in both of these publications, we express nitrogen in milligrams, or we express fertilizer rate in milligrams of nitrogen per liter. And that's a common terminology in these types of papers. And it's basically just, if you have to look back at the analysis of the fertilizer, and it's a relative amount of that fertilizer. It doesn't really have to do, you're not actively changing the amount of nitrogen in the ratio. It's just how much total of that fertilizer are you applying. So it's important to keep that in mind. And these papers are not about rates of nitrogen. They're about rates of organic fertilizer.
And they're not about identifying the type of nitrogen. You're not distinguishing between nitrates or ammonia. You're looking at strictly total nitrogen, you said?
That's right. But the ratios are available in the publication of ammonium and nitrate, for example.
Yes. And then the other thing I noticed when looking at that fertilizer mix, it was quite low in trace minerals, the copper, manganese.
That's right.
Some of those. Do you think that could have had some sort of effect on the trial itself or overall plant growth or yield?
To my recollection, we actually had a micronutrient additive in both of these in all the fertilizers.
I know for sure you had one in the flowering one. You might have in the vegetative, and I just totally missed it. That's probably the likely culprit.
Yeah, and even if there wasn't one in the flowering stage, it was only a period of maybe 20 days, so it's very unlikely to see micronutrient issues in such a short period. But in the flowering stage, definitely it was necessary. It would have been necessary, at least. We didn't try without it, but just based on experience, it's likely necessary. So
we could do further. There's plenty of further research to do in general, but around like optimal NPK levels, optimal fertilizer concentrations across various substrates, and optimal trace mineral levels, for cannabis.
Yeah. Oh, there's honestly so much to be done. I'm very interested in looking at the different NPK ratios and looking at, actually teasing out ideal pH ranges and substrate salinity levels is really important. Irrigation, all that, and keeping, it's really important, again, to reiterate, it's important to keep in mind that it's kind of a whole systems approach where you have to, if you change your fertilizer, you also have to adjust your irrigation and your growing medium and your lighting and the vapor pressure deficit in the environment and the CO2, and everything has to kind of be understood as a whole. And if you do portray the research in a way where you're expressing all those things, it's easier to take that information and apply it elsewhere.
That's a really, really good point. Yeah, I'm glad you mentioned that. And this is a little bit of a sidebar, but I just want to remind listeners that there are people out there that claim they know, the optimal amount of manganese a cannabis plant needs, or the optimal amount of zinc, or all these different minerals. But really, the research just hasn't been done. And so if they're that confident, I would be a little bit concerned about what they're actually saying or sharing, because I know you did quite a bit of research trying to find research, and it just doesn't exist. So I would just caution listeners around in that regard when people make conclusive comments regarding this crop or this plant.
Yeah, that's really important, and that's the number one issue I run into working with growers like I do now. So just for context, these two publications they're put out a couple of years ago. They were the first publications on fertilizer rate in indoor cannabis pretty much ever. So there's really nothing out there that's, in my opinion, of any validity other than these and whatever comes next for fertilizer companies to be basing their claims off of, unless they're doing really rigorous R&D.
Yeah, which is possible. And there are people doing research, and a lot of it they'll just claim as proprietary and not share it. But most likely, at least what I've seen in the fertilizer bottled nutrient industry around cannabis, is a lot of it is just speculation and claims and snake oil versus actual science to support what they're doing.
And I'd love to talk to you about that as well after the fact, because in my current position, I'm working with Hawthorne Gardening Company, which has acquired General Hydroponics and Botanicare, all sorts of other companies that service the cannabis industry. And my role is going to be to do exactly what we're talking about and try and figure out what makes these products work, how can we make them better, and how can we develop new products that are based off of good science rather than just claims.
Well, why don't we just touch on that now and then come back to these last two papers? You mentioned
Sure.
Hawthorne. I believe they're a subsidiary of Monsanto.
No, of
Scott's.
Miracle.
Scott's. I apologize. You're right. Of Scott's.
Yeah, no association with Monsanto.
That's true. You're 100% correct on that. I apologize. Well, they do sell Monsanto products, right? So there is a partnership there, but not.
Yeah, they have a license for Roundup, I believe.
Yeah, for the glyphosate. Yes. Okay. So I'm glad we rated that. But when we're talking about these companies that are coming into the cannabis industry, like Scott's, and funding around research in terms of who can afford funding, how do you see? One of the questions I had for you that I mentioned off air was, what do you see as the future of academic research with cannabis? Is funding going to be an issue, and who's going to drive really that funding once you have legalization, both here on the federal level, both here in the United States and in Canada?
Yeah, it's a very exciting time for research in cannabis. In my personal opinion, I've never found there to be limitations on funding in Canada specifically on academic research for cannabis. We have lots of, so working with the University of Guelph, we had lots of growers approach us and also vendors of specific products that want to prove their claims. And coming to university is a really great way of doing that, and supporting a graduate student or supporting some independent research to be able to actually, make the claims on your bottle or on your container, make them mean something. And so that's happening a lot, and I think there's a lot of potential for both companies and for academic researchers to bring some validity to some of these products and some of these claims. And there's a lot of work to be done, and it seems to be happening. So I know that Scott's, in acquiring all these companies, they're a company that backs all of their claims, and it's a very established company, and if they're going to say something on their bottle, they have to be able to substantiate it. And so now we're doing that work for all of these products that are being marketed to the cannabis industry, and so we're going to have that kind of level of rigor in the products that are being sold by Hawthorne.
Okay, and just to be totally transparent here, as someone who's not a huge fan of some of these larger companies, like Scott's and Hawthorne, in terms of their role in the industry, which is separate from the quality of their products or the research they're doing. I want to make that very clear. I'm not a huge fan of glyphosate, for one, but if we're talking about university research around products, and let's just take a General Hydro grow formula, for example. I think it's awesome that research is being done to improve the quality of that product. How do other companies compete and not be run out of the industry, assuming that they can't afford, the hundreds of thousands of dollars that may go into setting up a university trial?
So there's various ways you can do it. If you hire a scientist on your team who's a well-respected horticultural scientist to do trials on your product, and you can produce white papers or even publications yourself and prove that they're valid, then that's just as good. There's definitely an edge in having, we have a 40,000 square foot purpose-built research facility with dozens of grow rooms and, all these resources, which, in our purposes and for Hawthorne and for Flowr, which is the company that I actually work for, there's obviously an edge, and we're going to be able to answer these questions faster, but it doesn't mean that it's impossible for some of the smaller players to be able to do the same work to the same rigor.
I think that's a really good point. So there's nothing to stop other people from doing, research collection or data collection, their own research. I mean, we're doing our own research down at Goldleaf through that facility, but you're totally right about that. And I think, I think it's great that there is more research, and where that money's coming from can be a little bit challenging for people. But at the end of the day, like, as long as that research is published, it becomes useful information that everyone can kind of draw from and improve our overall body of knowledge around this plant. Do you see all the research though being published on the sorts of work that, at least what you're doing there in Canada?
There's definitely going to be some of it will be released. A lot of it will be kind of for the technical service reps to be able to inform the people that we're selling to, or that Hawthorne is selling to, what they're using and how to use it. But right now, it's we haven't done any of this work yet. It's still coming out, but there's definitely plans to put some of this out and to do some peer-reviewed publications, and really to increase the body of knowledge, because it, in my opinion, if you have these resources, it's kind of a responsibility to be increasing the body of knowledge for everyone, not just making claims on bottles.
So would you say, as a scientist, you're more of like a product atheist, in the sense that you're most interested in just furthering the amount of research and knowledge in the industry around this particular crop, and Hawthorne is able to provide you with a level of funding that allows you to do that research?
Yeah, let me clarify my position and with the Hawthorne Flowr and everything like that. So I'm the director of plant science at Flowr, which is a licensed cannabis producer, and basically Hawthorne has partnered with Flowr to build this facility. So we're experts in facility building, management, cultivation, specifically for cannabis, and we're probably the foremost experts in the world in that area. So my specific role is not necessarily to be doing the Hawthorne research, but to ensure that everything, like to work with them to make sure everything they're doing makes sense in terms of cannabis, and not just not mums or ornamentals that maybe they've done research with before. So I'm not stuck with any products or anything like that. I just want to make sure that science is being done well, and that it's widely applicable, and that people can actually gain something from all of this.
Yeah, for sure. Please don't take my comments as trying to give you a hard time about any of this.
I don't. I know I'm not. I just wanted to clarify.
Okay. Well, cool. I'm glad we touched on that, because I think that's important. And I think that's something. This is a little bit of a tangent, but when we look at research and how it's funded, I think that's something that you should always consider too when you're looking at research, is who's paying for that study and why are they doing that. Can sometimes create a little bit of bias around results, but at the end of the day, it's still more useful to have that information out there and have something be peer reviewed. I think is really important.
Yeah, I agree.
So, all right, let's dive into these other papers that I'm actually really excited to talk about. Do you want to do the propagation one or the stress testing that you did?
Let's talk propagation first.
Cool. Okay. Well, you want to just give me some of what you set up with this trial and what some of the highlights were, kind of the abstract?
Yeah. So this trial came about basically, working with Vivo and working with other cannabis producers and observing some of the horticultural practices that they were doing as we were doing other research. We're working on the fertilizer stuff and working on the growing media work. we found that some things maybe didn't make sense to us as horticultural scientists, and just with basic understandings of plant physiology and propagation, for example, and what with this paper we looked at propagation. So we found some interesting practices. One of those was that growers are often cutting the tips of the leaves off of their clones before they're cloning them. We also found that there was a lot of kind of widely held, strongly held beliefs that you had to take cuts from a certain area of the plant. And we just wanted to kind of, test it out and see what's right, because a lot of these growers have been doing it for decades, and their knowledge is incredibly valuable, especially in the absence of the literature. There's no literature, so we really have nothing to base our horticultural knowledge on. So we wanted to kind of tease apart some of these factors that growers were regularly choosing to go with. And so we did a fairly large trial on how to improve the success and quality of cannabis stem cuttings or clones, looking at 4 factors. We looked at the number of leaves on the plant, on the cutting. We looked at whether the tips of the leaves were removed or not. And we also looked at the position of the cutting, so either from the top or the bottom of the plant, the apical or the basal region. And we looked at 2 rooting hormones. One was an organic willow-based extract, and one was a traditional IBA rooting hormone.
Yeah, great. So what did you find? And when you say the cutting the tips of the leaves, you're talking about, you define that as removing 30% of the leaf from the outside. Most growers are going to know exactly what you're talking about, because it's something I did the very first time I cloned, because I was told that's what you were supposed to do.
Exactly, yeah.
Yeah, what did you find with this?
So I'll start off with the most interesting finding. Basically, we found that cutting the tips of the leaves in pretty much every situation reduced rooting success by about 20%. And as a plant scientist, it makes sense. You're damaging the plant, you're causing a wound, and you're reducing the photosynthetic area in a way that's also you could decrease the area, the number of leaves, which has the same effect of removing the tips of the leaves if you're just looking at leaf area, but you're causing a wound as well. So it kind of made sense, and it was really interesting. And I've talked to a lot of growers, and they've already changed their practices based on this publication. So I was really, really happy to find that. Some of the other findings are also interesting. We found that in terms of rooting quality, so not just if they rooted or not, but kind of how many roots the plants produce after they rooted, we found that 2 leaves had quite a bit higher rooting quality than, 3 leaves had higher rooting quality than 2. We also found that the IBA-based rooting hormone drastically increased the rooting success, which we kind of expected. But that doesn't mean that there's not an organic alternative. It just means that this specific product didn't work very well. And yeah, the biggest finding there was the cutting of leaf tips.
Yeah, that's a huge one. So the way it was described to me was you want to cut the leaf tips off because you want the plant to focus its energy on rooting, not so much on photosynthesis and trying to grow. So that was why you're supposed to do it.
Yeah.
But what you're saying is you do not, science shows based on this study, do not cut the leaf tips.
That's right. So there was 2 reasons that I heard for this practice. The first is exactly what you just said, is focusing the energy. If plants don't focus energy, that's not really how plants work. But I've heard that a lot. The other one that makes a lot more sense is just reducing clutter in the propagation environment. So if you're growing in a dome, if you're rooting under a dome of high density, if you're using a Rockville slab, for example, then you're going to run into issues with damping off and root pathogens. And if the leaves are really congested and shading each other or touching each other, then it's more likely that you're going to proliferate these root pathogens. And so reducing the leaf area makes a lot of sense in that situation. But if you have fewer leaves, we found that you don't have a lower rooting success rate. You'll just have a slightly lower root quality. So that's kind of the way to mitigate that problem, is just to have fewer leaves instead of actually damaging the roots, because then you're even you're opening wounds to let the pathogens in, and it's a whole other situation.
So it's better to remove an entire leaf than it is to cut the leaf tips if you need to
That's right.
reduce it. And then you didn't really touch on humidity. That was the other thing. The other reason I heard, now that you kind of reminded me, was that it'll reduce the amount of, transpiration and humidity under that dome situation.
Yeah. So when you're taking cuttings, they don't have any roots. So with vegetative stem cuttings, literally all the moisture to keep those plants from wilting is coming from the environment. And so you do want to maintain very high levels of humidity, but with that humidity comes higher instances of root pathogens because they also like that high humidity. So you just want it to be, humid with good air circulation, and you don't want the plants to kind of be touching solid surfaces or touching each other, because then you have these pockets of condensation on the leaves, and that's really the worst situation for root pathogens.
So maybe we need to design our propagation spaces to be a little bit better spacing in between the clones rather than
That's right.
other options for controlling that.
Yeah, so that's what I've seen. A lot of growers have moved towards that, just spacing out their clones more. But then you need, 2 or 3 times larger propagation environment. So what I've been working towards with Flowr, which I can't discuss in too much detail, but it's just ways of mitigating or controlling the environment such that you can have those high densities and still produce very high quality cuts. And all you have to do is, control the environment a little bit.
Now, from an organic perspective, what do you think about the possibility of testing other types of organic rooting hormones, things like what might be found naturally in kelp, or I know people use a lot of mycorrhizal fungus, which I'm not convinced makes any difference in a cloning situation. But I know some people have made claims around that. I'd be curious to hear your opinions around mycorrhizal fungus. And then aloe is another one that I've seen a lot of people moving towards with cloning. Can you talk about any of those as options for at least some new research or anything you know about them?
So all I can say is that I didn't find anything in the literature to suggest any other organic alternative rooting hormones that actually work. Not that they don't work, because especially with organic, just like we talked about previously, that it's very hard to do research on that. So often people will just find a product or practice and it'll work, and they'll just continue doing it, and that kind of gets overseen by scientists. So there's probably something that works. I haven't seen anything else that works anywhere near as well as an auxin-based rooting hormone, but I would love to see it if someone figures something out.
So we need further research on that sort of thing is essentially where we're looking at.
For sure, yeah.
Cool. Well, any other highlights from the propagation one? I know we didn't touch on it for very long, but I think you really nailed all the big points there. Was there anything else you wanted to highlight from that?
The one small point that I didn't touch on was that there was no difference in rooting success or root quality based on where you took your cutting, so from the apical region or the basal region, the top or the bottom. And that's really interesting because, again, that's a commonly held belief that taking cuttings from the top of the plant will give you a better rooting success. And that's actually founded on something in other plants that is the case, but in this situation, it was not the case for cannabis.
That is really interesting. One other thing I want to touch on too that you mentioned is, and this is a quote from your paper, cuttings from juvenile plants generally have improved rooting over those from mature plants, Altamura 1996, and juvenile plant material sometimes has a higher content of endogenous auxins and other rooting promoters compared with mature material. And you quoted Hewson and Powell 2006 on that.
Yeah, so that's basically what I said. So other plants have more distinct mature and juvenile regions that have, again, more distinct levels of hormones such as auxins that will influence the way that they root when you take stem cuttings from them. So again, that didn't appear to be the case with cannabis, but it is the case with other plants.
So do you think that there might be a case for keeping mother plants for shorter amounts of time based on any research that you've done in terms of, keeping a mother plant for 6 months versus changing out your mother plants more frequently? Any thoughts on that?
Based on my research, nothing. No, I haven't seen any preference either way. Like from experience, there is definitely a difference if you're working with a 2-3-year-old mother plant. There appears to be difference, but the reason for that, I'm not sure. I'm not sure if there's some kind of genetic reason, or if you just have increased viral load in the plants, or the plants just have these kind of accumulated levels of stress, which changes some of the hormone levels. That's another research question, to be honest.
Okay, great. Well, let's talk about this paper that I'm probably most excited about. I mean, they're all really, really great and interesting, but stress is and stress response is just such a fascinating topic when it comes to cannabis. Do you want to talk a little about the trial that you set up, or the study you worked on here?
Sure. Yeah. So basically, it's pretty well documented in the literature that drought stress specifically is a major stimulator of secondary metabolites in plants. And so a recognizable example of this is in herbs and spices that are grown in regions like the Mediterranean that are semi-arid. So they have intermittent drought stress and lots of sunlight, and those factors are linked to more aromatic herbs and abundant essential oil. In the literature, we didn't find obviously anything on drought-stressed cannabis because there was, again, nothing. But we wanted to see if we could apply a controlled level of drought stress to cannabis and see if we can elicit some positive response in terms of cannabinoid content in the dry flower or terpene content. So that's the general gist of what we wanted to do.
Okay, and then so how did you determine the parameters of this? Because one of the other things you touch on is how drought stress timing is also really important in terms of minimizing yield or dry weight loss and maximizing your essential oil yield and concentrate of these metabolites. How did you come up with the rates that you did?
Yeah, so drought stress is an incredibly complicated stress to apply, as I found in doing this research. So there's a lot of ways you can apply drought stress, and I'll talk about the timing as well. But in terms of just application of drought stress, you want to reach a certain level. You want to quantify stress, which is a difficult thing to do, and you can also apply the stress in different ways. So you can, like you were saying, you can control the moisture content. Like the project that you're working on, you can control the moisture content to a certain level and just maintain it at that certain level. And so that's one way of applying drought stress. The other way is growing your plants in a solution that has a very high level of salts, and that mimics drought stress because the plants can't actually uptake water. But if you're trying to replicate how drought stress is, happens in nature, it's through gradual substrate drying. So the soil, for example, would dry to a certain point over time, and the plant would experience stress incrementally over that period, with starting with very little stress and then more and more stress until eventually the plants are rewatered. And so that's what we wanted to mimic. And in terms of the timing, so this was a preliminary trial. It's the first of its kind. So we wanted to do one treatment that we thought would have the most effect. So we looked at when, in general, cannabinoids, how they accumulate over time, and we picked the point of maximum accumulation to be the point when we applied the drought stress, and that was fairly late in the flowering stage for the cultivar that we use called Nebula.
So when is that Nebula cultivar typically harvested? At what sort of day of flower, and when did you apply the stress level, the drought stress?
Yeah, so I believe we harvested at 9 weeks after changing the light cycle, and we applied the drought stress at week 7.
Okay. Yeah, because I've seen, it's a common thread among growers. They'll stop watering for the last week or the last few days, or they'll make massive changes with the lights. I've even heard of people, changing the conditions in their grow room quite dramatically in terms of temperature. all these different ways of triggering stress. So you went with, at 7 weeks, you allowed the plants to visibly wilt. I believe that was one of your drought stress indicators, and
Right.
at least the most practical one for growers to look at.
Yeah.
What did you find when you did that?
So, okay, in terms of the drought stress threshold, so actually determining when the plants were stressed, we looked at wilting, which again is something that growers can actually see. But wilting, wilting response is not the same between species. So some plants will be very damaged before they wilt, and some will wilt way before they experience any permanent damage. So it's not really you can't just assume that it's a good indicator of stress. We did find that it was a good indicator in cannabis, which is useful now, but before we couldn't make that assumption. So we used these pieces of equipment that are very high tech and pieces of equipment called in situ stem psychrometers, and this is something that was invented by one of my advisors. It's a device that connects directly to the vasculature on the stem of the plant, and it measures in real time the plant water status, which is effectively kind of like the pulse of the plant. So if it really needs water, the water status will change, and you can even flick a leaf and you'll see in real time a change in the water status. It's that sensitive. So there are, regardless of wilting, there's standards in water status that will tell you if a plant is stressed, and we use that as our drought stress threshold, and then applied that to wilting after the fact.
That's so cool. I wish I wish I could play around with one of those. So it's measuring essentially what's going up and down through the xylem. Is that right, or am I?
Yeah, it's not necessary. Yeah, there's
Or up.
somewhat there's sap flow meters, which measures flow, but this is more measuring water status. So it's a metric of kind of the water pressure a plant experiences, which is a function of the environment. Well, any change in the environment will affect water status. So if you increase your lighting, there'll be more pressure on the plant to transpire. If you change your temperature, your humidity, your vapor pressure deficit, all of that kind of relates back into the water status of your plant. So it's a very good accumulator of the plant's response to the environment. It's the best that we know of right now.
That's really cool. Yeah, I didn't even know that something like that existed. That's awesome.
Yeah.
So you also looked at relative leaf angle, as that's something that growers might be able to do as well as wilting. Yeah. So based on your research, now you're saying that cannabis does allow you to use wilting and leaf angle to show or demonstrate drought stress, which is important to know.
It is, and it was way too difficult to figure that out, but we did figure that out. So we found that when the leaf angle of if you look at a secondary branch and you're looking at a fairly large fan leaf, when the leaf angle of that fan leaf went from decreased by about 50% from its original turgid angle, then it was at a level where it was actually experiencing a significant level of stress.
So when we talk about plants praying, with their leaves pointing up like that, across, most cultivars that I've seen, really it's the turgidity of the stem or the leaf. How does that correlate with plant health, or is that something that you can talk about at all?
Yeah, well, I can speculate. There's no research on that, but in general, that's a sign of just really heavy transpiration, and transpiration where the plant has enough water and is actively transpiring. There's a very high VPD in the environment, and it's really pushing out water. And often you'll see a correlation, again, speculation, but between that and just very healthily transpiring plants.
Cool. So there may be a correlation there visually.
There may, but I've also seen cultivars that do that regardless. So it's
okay.
Not sure what it means.
That's a good point then. I'm glad you mentioned that. Cool. So I want to talk more about stress responses and the numerous stressors that can be in a given grow environment. But before we do, let's talk about your results just relating to drought stress. So what were your findings in this paper?
Okay. So After we gradually let the substrate dry in our drought stress treatment, we found that the photosynthetic rate was drastically reduced over the control, so the plant was really suffering. And we re-wet it, and we measured, all sorts of parameters during and after. So we confirmed that there was drought stress. And the most interesting result was that there was no difference in the yield between the control and the drought stress plants. And there were some increases in some of the important secondary metabolites. So we found that THCA concentration in the drought treatment increased by 12%, CBDA concentration by 13%. And if you look by yield of the specific cannabinoid, so grams per plant or grams per unit area, we found even higher increases. So CBDA was increased by, or CBDA yield by 43%, CBDA yield by 47%, and so on. There was a lot of very interesting increases by just applying, drought stress once at week 7 in the flowering stage.
That's fascinating. I don't have much to add to that other than I think it shows just what effect drought stress can have on your overall yield. I mean, I don't know quite how to apply that across other forms of cultivation, but I think that's just fascinating that you got such a strong result.
Yeah, and you know what? I'd love to talk about kind of the intricacies of that, because, like as you say, to apply that elsewhere in this situation is even more difficult, because it's the accumulated stress that the plant perceives. So it's, the stress, like I said, it increases over time, and it starts from very little to quite a substantial amount of stress, but it's the accumulation of that stress that the plant actually perceives. So if you were to go to wilting point in a 4-inch Rockville cube, for example, it would take a day. And the accumulated stress would be vastly different from if you're working in a 3-gallon pot with, a peat-based growing media that takes a week before it gets to the same wilting point. So it's very important to consider that, don't just let your plants wilt, because it's not necessarily the wilting that does it. It's that it's a certain amount of stress over a certain period of time. So if you apply, if you get to the wilting point in 6 or 7 days, you're more likely to actually see the benefits that we saw, rather than doing it in a couple of days, for example.
Yeah. So how do you feel that drought stress is the best type of stress for cannabis, or do we even know? I mean, so one of the things I wanted to talk about with you was there's all these different forms of stress in any given grow environment for a plant, whether it's environmental with, humidity and temperature and BPD, whether it's lighting, watering, pest pressure, how do we as cultivators, what sort of applied science or knowledge is there out there for how we sort of control these stress responses, and which may be beneficial and which may be, detrimental to yield, health, all of those things?
Yeah, it's a very interesting question, and I've been very, very interested in that for a long time. Stress is a kind of dangerous tool to play with as a grower, because it's so easy to do damage. It's intuitive that stress can be damaging to your plants. And, even if you're doing it late stage after it's fully grown, I've seen decreases in yield, decrease in cannabinoid content if you're over applying stress, late in the game, or, especially if you do it too early. If you do it during the vegetative stage, almost across the board, you're going to have decreased yield, decreased everything. So you really have to be careful and do it in a really controlled way. Only apply one stress. I don't believe anyone who says they can apply cold stress and salt stress and drought stress all at the same time and know how that's affecting their plant. It's vastly more complicated than I think anyone understands right now. So if you're going to play with stress, I would suggest one thing: just work with one stressor. Go ahead.
Oh yeah, I just wanted to add to that. So what I found from visiting a lot of different facilities and such is that every facility has some form of stress already occurring fairly regularly. There's no perfect environment. These growth chambers that you're creating are very hard to scale for growers when we talk about commercial production of cannabis.
Oh, yeah.
So how does that, when we talk about, you mentioned applied science, how does that come into play when we're talking about a facility? Like if you were a grower listening to this talk and you're like, wow, I hear you mention stress, I want to start playing around with stress. What would sort of be you mentioned some cautions already and just trying to go with one form of stress, but I don't know. What do you think about that?
Yeah. So the grow rooms that I'm currently operating in are kind of like large experimental growth chambers. They're about 1,500 square feet of grow area, and they're very, very controlled. So I'm fortunate that I can play with these. But if you're operating in a less controlled facility, the plants perceive a lot of the different stresses in the same way. So salt stress, cold stress, drought stress, they're all effectively just a different form of drought stress. So they're just limiting water uptake by the plant. So if you have high levels of salt, water uptake is restricted. If there's less water, so if there's drought, water uptake is restricted. If it's cold, the plants can't transpire as much, so it's restricting water uptake. So a lot of them are effectively the same stress, and you can just apply it in different ways. So the easiest way, I think, is in using the salt content in your growing media. So if you do want to apply a drought stress, or you can just increase your fertilizer content whenever you want to apply that drought stress. So for example, if you wanted to do it in week 7, like we did in this paper, you could increase that to a point where you're fairly confident that the plants will have a restricted uptake of water. You can even, let them get to wilting point that way, and then you can relieve the stress after the fact. So working with your fertilizer, or even if just, adding salt into your fertigation mix, that could be one way of doing it. But again, you're kind of playing with fire, and it's best done in a very controlled setting and then scaled up later on. So I would never recommend to a large scale grower to just go and start playing with stress.
Yeah. And one thing about your trial that I thought was an interesting decision you made was you were using the same level of fertilizer in the water, I believe, if I read it correctly. And then the plants that were drought stressed just received less water. So overall, they received less fertilizer. Can you talk a little bit about that? And because you said yields were the same across both, could there potentially have been over fertigation in the other crop, or does your other trial that you did sort of validate the fact that the fertilizer level was appropriate?
Yeah. So again, that's one of the intricacies with doing drought stress trials, because if you are, so for example, if you weren't fertigating and you just didn't incorporated fertilizer in both treatments, and you drought stressed one and not the other, then when the substrate has less water in it, it also restricts nutrient uptake, because again, nutrients are mostly taken up with water. So you can do it that way, or you can fertigate, where you're adding nutrients every time you irrigate. And that way, again, if you're fertigating your control more frequently, it's getting more fertilizer. But I've never seen a drought paper that has any way of mitigating that problem, because those two factors, the fertilizer uptake and water uptake, are very, very tightly connected. So our only kind of way of negating that effect was to look at the other publications that we've done, and we saw that cannabis responds similarly to fertilizer rate within a specific range. And we saw that both of the control and the drought treatments fell within that range. So we were fairly confident that it probably did not influence the yield. Plus, the fact that the drought treatment, which received less fertilizer, actually had higher yield and cannabinoid content, which we would have seen probably based on our other publications that it would have been the opposite, because we weren't over fertilizing the control in any way. So.
Okay. Yeah. I mean, I think this kind of just goes into some of the intricacies of trying to design sort of a rigorous trial. There's just so many variables that you have to look at.
Exactly. And you have to consider that kind of thing. There are definitely a lot of variables to consider in any horticultural experiment. So
yeah, very important. And you have to, when you're looking and evaluating an experiment, I think before jumping to any conclusions, you have to look at the methodology that they chose to, because as a researcher, you're constantly making those types of decisions into how you're setting up a trial, and they have effects on your overall results. So I think that's
Yeah,
great.
that's right.
So when we talk about stress, anecdotally, I've mentioned this on the podcast. You have the guy who has throws out an old clone or something, or an old plant onto the compost pile, and it ends up growing massively and doing way better out in this horrible weather conditions versus their controlled indoor plants. Or it turns out being the sad looking plant, but maybe is the best cannabis that they've ever grown, in terms of a crop. So we know that stress has an impact. Do you feel like besides drought stress, there's any other areas of sort of stress response that we could look at for increasing, some of these cannabinoids?
Yeah, I think that like there's a lot of different stressors that can have some positive impacts, but in most of these cases, you'll see a reduced yield but higher concentrations of chemicals, and if that's what you want. If you want like the most potent cannabis possible, then grow it healthy for a little bit, stress it. You'll have lower yield overall, so you're taking that as a loss. But then maybe you'll have more potent flowers. So it's a cost benefit for most growers. So yes, it's something to play with. But if you are selling your flower by yield, which generally you are, maybe it'll sell better if it's a higher THC content, but still total volume is by yield, then sometimes it's not best to apply stress. But it's really up to the grower and kind of what they want to grow and how they want to do it.
Yeah. So for me, this is challenging. So my thoughts on this are every facility has a lot of environmental stress already for plants. Just as a general rule, there's no perfect facility out there, at least that I visited. So I'm assuming that every plant is receiving as much stress as it probably wants or needs, and that the goal, as someone who works in cannabis, is to reduce the amount of plant stress we see. Healthier plants, less pest pressure, less drought stress, all of those things, in terms of increasing yield. Because I'm just assuming that the plant is going to receive stress from, because there's a lot of things that aren't natural stressors in the environment. If we want to talk about a cannabis, life cycle outside of cultivation, we're looking at a plant that's not cloned, it's not transplanted, it doesn't have its light cycle switched in a 24-hour period to something completely different, and the light intensity ramped up so quickly. How do you think that factors into plant stress or cultivation from a practical perspective?
Yeah, I think as a general rule, it's best to first reduce all the unwanted stress in your growing environment. So like if you're working in a greenhouse that has variability in humidity from one side to the other, get rid of that variability first. Get rid of the differences in light intensity across your canopy. Make it as uniform as possible. Once you get to a point where you're fairly confident that your canopy is uniform, you are growing, you're not overly stressing out your plant when you don't want to be, then there might be benefit in applying controlled stress. But until that point, like you say, there's so many stressors that are already occurring to your crop that are unwanted. It's not worth applying one more.
Okay, so just your exercise caution at this point in time.
Exactly, yeah.
So what do you think about natural versus sort of artificial stressors and in relation to genetics? So I was talking with Ben actually earlier today about this in relation to your work. So we have these unnatural stresses in terms of transplanting, cloning, light changes that wouldn't occur in nature, but plants may have, certain cannabis plants may have been, evolutionarily selected for this based on the way that we have been propagating and breeding them, indoors under these lights for numerous, decades now. How do you think that factors in when we talk about it from, like, say, a genetics perspective?
Yeah, I think it's a dangerous game to start comparing how plants want to grow naturally compared to how we can grow them in controlled environments. So the lab I worked with, or I studied with, is a controlled environment research facility, and we'd study how to grow plants in harsh climates and space and very, very controlled environments. And basically, decades of controlled environment research have told us that plants, if you can control the environment to be exactly what the plant wants all the time, it will grow much better. You'll have much higher yields. You'll completely beat out nature. There's not even any question about that. So I think it's a dangerous game to start trying to mimic exactly what nature does, or how nature applies stresses, or how nature, how plants grow in their natural environments. Because once you have a general understanding of how a plant grows, and you can start tweaking things like the CO2 concentration, the light intensity, the light uniformity, when plants receive light, the spectrum of the light, all that. If you can optimize all those parameters in a system that makes sense, there's no question that you can beat out nature. And that's been seen with NASA research trying to grow tomatoes to the best of or wheat to the best that it could possibly grow. It's vastly superior to yields you would see in the field.
It's like steroids with humans. So what about photoperiodic plants? Have you seen any research relating to that in terms of genetics? So I know that's more specific to cannabis than most horticultural crops, but
yeah.
I'd just be curious because I get what you're saying. You're saying that we can't really necessarily assume that mimicking nature has any sort of advantage in terms of yield or plant health, and that we're able to do it quite well in these what we're calling unnatural environments. But how, I guess, for plants that may be genetically or evolutionarily brought up to be grown under a certain environment that seem to thrive in this environment, is there any sort of relation there in terms of other crops that have been found that are photoperiodic, that have been found to also maybe over time have their genetics change for the better when we talk about a specific type of cultivation?
Yeah, I think it's been kind of regardless of that. It's been more kind of breeding selection for cultivars that perform well in the environments that we're growing them in. So it hasn't been done really in a controlled way for cannabis, compared to crops like wheat or corn, but it's still been done for decades and decades, where growers will find a cultivar that really responds well to being triggered in 12 hours. So in a big phenotyping project that we're doing now at Flowr, we've seen that some cultivars will switch at 16 hours, and some will only switch at 12 hours. And so it's likely that breeders of the past have kind of just selected the ones that respond well to the way that is easiest or safest or most efficient to grow them in.
That's interesting. Cool. Well, I know we talked about a lot today. Was there anything you wanted to add regarding the research that you've done, or anything you want to touch on in terms of upcoming research that you're really excited about that you're able to talk about?
Yeah, well, in terms of upcoming research, that's been kind of on the forefront of my mind. And so right now I'm acting as the director of plant science at Flowr, and I'm working with a team of plant breeders, engineers, growers, other horticultural scientists, and kind of the potential and the backing behind improving this crop, even just in my kind of closed circle, is incredible. So there's so many people so interested in learning about this crop and improving it, and there's so much value in doing so for a large scale producer like Flowr. We have production facilities all over the world, and one small improvement can mean huge increases in yield or in quality, in our Portugal operation, where we have 165 hectares of outdoor space, or in our local Kelowna production facility, where we're growing indoors and also in polytunnels. And so there's a lot of effort being put into research, and there's so many low-hanging fruit to grasp for, and that's kind of what I'm doing now, and what me and my team is working on is trying to understand this plant and how to grow it better. There's going to be so much to learn in such a short period of time.
Yeah, well, I really appreciate the research that you've done, and I thank you for sharing it so openly and getting it peer reviewed, because I think that has a lot of value. And like you said, you're just on the cutting edge, sort of the tip of the iceberg for the amount of research that is going to be done. And I'm really grateful that we're starting to see this type of thing. And I hope I can have you back on to talk more about it and some of your new research, and maybe debunk some more of these sort of myths or practices that may have not been beneficial, like you mentioned with the cutting the leaves and propagation. So yeah, thank you.
Yeah, I'd love to. And I really appreciate you having me on and giving me a platform to share.
That was horticultural scientist Deron Caplan, and you were listening to the Cannabis Cultivation and Science podcast. I'm your host, Tad Hussey. Don't forget to check out our website at www.kisorganics.com for more information and resources. Sign up for our newsletter on our website homepage so you can stay up to date, as we have some new research going on regarding blue mats, lighting technologies, and much more that we hope to publish soon. Give us a follow on Instagram, it's at KISorganics, and leave us a rating and review on whatever platform you're listening on. Thanks for listening.